Yeah, so we want to make a proper interpretation of the language here in LS10. We're looking for a function at h for which one of the level sets, okay, pause, we're going to be taking this function h and setting it equal to some constant. That's what, if we're saying we're looking at one of the level sets of h. So h equals c is going to come up here. Now, on the other hand, we want this to relate to the graph of the function f. Pause. What is the graph of f? Well, you take f, formula for f, you set it equal to a new variable, perhaps called y, let's say, because f is just a function of x. And that's going to give us also an equation. And I want those equations to be the same because I want one of the level sets of h and the graph of f, I want those to be the same thing. So therefore, those equations have to be equivalent. So let me go back to the thing here. So let's write down, so I want the equation h equals c to be equivalent to the equation y equals f of x, which is x squared. So, and now you got to just, how do you do this? I mean, what function could I possibly set equal to a constant and have the resulting equation be equivalent to this? Well, there's lots of different ways to do it. I could rewrite this as y minus x squared equals 0. Oh, look at that. Here's a function, and I'm indeed setting it equal to a constant. So we're looking at a level set of that function, which I'm going to call h. So h of x comma y is y minus x squared. Note that h is a function from R2 to R1. All right, and I claim that the 0 level set of this function is described by that equation. The graph of f is described by that equation. And note these two equations are logically equivalent. So this is your function h. Does that make sense? You have any questions, or are you just digesting?
Just digesting.
Okay. Anybody have a question about this?
So the level sets, is that R2 to R1?
Yeah. This is from R2 to R1. Yeah. Do I write too small on here, by the way? Should I write larger?
No,
it's okay? Okay. All right. Okay. Yeah. Yeah. Go ahead.
For some reason I thought it was R1. It might be R1 to R1.
Well, I mean, so the original function f is. See, f goes from R1 to R1. So that's the thing, the graph and level set constructions are so different that, we've talked about this before, but level sets live in the domain, graphs live in this sort of, this weird combination space that has both independent and dependent variables in it, and it's a totally different dimension. So that's, these constructions are dimensionally very different.
I guess because when I did I knew the graph was in R2, so I drew the parabola.
Yeah.
And then because from the original, the domain was R1, I thought that the level set would be R1, because it lived in R1.
No, so the graph of f lives in R2. So here's the thing: we're not talking about level sets of f. We're talking about finding a function h that we can take level sets of that would give us the same thing as if we took the graph of f. So this is the graph of f.
And they want that to be the level set.
Yeah, that's right. And we want that to be the same as a level set of h.
How do you know that you're going to map in? How do you make that connection that you're going to map in R2 to R1?
This here?
Yeah.
Oh, well, I just sort of looked at what I had here. This is a function that involves two variables x and y. Let me say that a little bit more accurately. I know that h has to be a function from R2 because the graph lives in R2. This is a subset of R2. And level sets live inside, this is a subset of R2 also then. And level sets live inside of the domain. So that means that the domain's got to be R2.
Because I was just thrown off by the R1 to R1.
Yeah, so f
Is it just because you're replacing the function f of x with the new variable y? Is that why it all of a sudden jumps to?
Yeah, that's this weird feature of graphs that you take a function like f. It's got a one-dimensional domain. It's got a one-dimensional target, and so we're going to represent this geometrically in R2 for some reason. I mean, it is a strange sort of counterintuitive construction.
So you're replacing the f of x. That's what's happening when you're taking the new variable y.
We're not really replacing f of x. It's that we're forming an equation that involves both input and output variables. Yeah. Yeah.
So when you said
Sorry. Yeah. Go ahead.
When you said domain, you're not looking for like y should be greater than or equal to 0. That's all you're.
No, and that wouldn't even be required. I mean, all we have here. I mean, this function h is a function from all of R2 to R1. This is perfectly well defined at any vector in R2. Right, and it's just that I will happen to be looking at a particular level set of that function, but that function is defined everywhere. Yeah, and you had a question. Yeah.
So I guess the domain is pairs of x and y such that x is a real number, y is a real number.
Yeah, and that's just easier to write. It's just R2.
Okay.
Yeah. I mean, but that's exactly what R2 is.
Right. So that's what you can write for the domain. Just say R2 to 1.
Yep. Yeah. So the problem, what's the domain of H? So you would say domain of H is R2. Yeah. In fact, honestly, if you write this here, if this explicitly says that the domain is R2, so you don't even really have to write that at all.
Okay.
Yeah.
You did f of x minus x squared, so there's more variables.
I'm sorry. What now?
So you did y minus x squared.
Y. Yeah.
Like in the second step, so that's like f of x minus x squared. So if you had more variables, if it was like not just x squared, but x, y, z, and all those variables, would you distribute the negative?
Well, I mean, I suppose that this is f of x minus x squared, but I wouldn't really recommend thinking of it. And that's not really the point. The point is that when we take this function, we form the graph. The graph is represented by this equation. I now want to interpret this y as being a variable. I don't really want to think of it as being f of x anymore. I want to think of this as an equation involving two variables, because I need to turn that into an equation involving what are eventually going to be two independent variables. Does that make sense?
Okay.
So you're wondering if this function was had several variables, yeah, then you'd have like f of x1 comma x2 maybe equals y, and so you'd have y equals x1 squared minus x2 cubed or something, and you just take that equation, whatever the equation is. I don't even really care what's on the right hand side. Just toss everything over to the left hand side, and that gives you some expression equals a constant, namely 0. Yeah. Yep. Yeah.
I have a quick question about dimensions.
Yeah.
Is it true that a graph of a function that has n input variables, then the graph will be either n dimensions or n plus 1 dimension?
The graph. Let me stop this, and then I'll answer your question.